Welcome to this video about my new prototype of atxflip. This is basically a little module that you can put into a standard PC, which then emulates the logic which you would normally find on an ATX motherboard to do the soft power switching. So you can push the power button and the whole system turns on, and push it again and it turns off. And this is basically what this board emulates to allow you to hook up AT motherboards to ATX power supplies. And the way you normally do this is by getting an adapter, a commercially available adapter from ATX to the old AT standard connectors. And the problem with that is that you need a real switching type switch, which latches and mechanically switches, and that requires you to change and swap out the switch found in your computer case. Also, old AT motherboards normally have a turbo function, and that is another problem because you can't basically enable the turbo function without drilling holes into your ATX case and putting a turbo switch somewhere. So this board is a rather old project for me. I've started in 2013 by building a 74 logic gate version of this, basically just using a flip-flop and some electronics, some latches and stuff for debouncing. And that worked reasonably well, because as I found out, motherboard type switches normally found in PC cases are quite bouncy and don't really work that quite nicely. And yeah, this newer version uses an tiny 85 microcontroller. It has software written in C. And on its default configuration with both jumpers set, you can configure basically everything with these two jumpers. In the default configuration with both jumpers set, you can turn the power supply, which is hooked up here, on and off. This switch is the exact same as the external power switch you could connect from your case, which you would do on this pin here with this prototype. And if I go ahead and switch it by pressing the button, the first indicator LED goes on and the power supply starts spinning. So basically this LED is hooked up to the ground of this LED is hooked up to the green line of the power supply cable, which then switches on the power supply. The way this works is the tiny microcontroller pulls down the green line on the motherboard and on the ATX power supply, which is screwed in here. And by pulling down the line to ground, it basically just enables the power supply. The way this works for basically in the sense of power for the board is we are screwing in the purple wires here from the ATX connector, which carry the 5-volt standby power. These two terminals, in these two terminals, you screw in the green wire from the coming from the motherboard from the power supply with the enable pin, basically the power on pin. If this line, the green line, is pulled low to ground, the power supply turns on. And of course you need a ground reference, which you screw in here. The 5-volt standby power and the ground line are given through to the connector. The green line is not connected through, although you screw in both terminals. One is completely unconnected, and the other one is basically only the one that goes to the power supply is the one that is really connected to the main chip here. So this cable, which I've screwed in here, is a regular converter cable. As you can see here, this is one of the wide 24-pin connectors. On the other side, it has a 20-pin connector. So it's one of these really cheaply available, like €2, adapters from 24-pin to 20-pin. They are quite nice for this project because you can just chop up some cables in the adapter itself, and you don't need to mess around with either missing cables on your ATX to AT adapter or hack around with your real power supply cables. You can basically leave everything intact, just hook in this thing as one unit into your into your standard PC setup, and everything just works fine, which is quite nice, I guess. One of the main features of this board is the switchable behavior. You can either select with the behavior jumper down here, select standard AT mode, which is basically a flip-flop mode. If you turn it on, it turns the power supply on. If you turn it off, it turns the power supply off. If you click it again, it turns the power supply off. And you can just do this the whole time. Yeah. If you switch the behavior pin out like this, and then if you switch one of the jumper settings, you need to completely restart the board, and you could do this by unplugging the connector, or by completely switching off the power supply and then waiting for it to turn off, which takes a lot of time, like this. So now it's turned off. I've turned it on again, like this. If we now turn on the power supply by clicking here, we are in the second behavior mode. We can click as much as we want here on this button, and it won't shut off. What we need to do is exactly the same as with modern PCs. In protected mode, x86 protected mode, we need to hold the button down for a couple of seconds, like this, and it eventually will shut off. So this is quite nice because it prevents accidental shutting down of your PC, which of course you don't really want. And also it allows for another really cool thing, and that is switching the turbo mode in software with the power button. And the way this works is I have two indicator LEDs here. The second one, as you could have probably guessed, is the one that indicates whether the turbo is turned on or off. And if I now click the button to turn the power supply on, like this, and I now hold and then release the power button for over 2 seconds, like this, the second LED comes on, which means it has now enabled the turbo line. We can still go ahead and turn the power supply off. The turbo line will stay switched on. Of course, in the final PCB, these LEDs will probably not be existent, because you will see what your PC is doing when it's really doing the things. This is just for debugging. But the nice thing here is the turbo line is permanently switched to ground, which means that the PC will directly start with the higher speed. And yeah. So if we now turn it on again and hold the button down, yeah, not like that. 1, 2, turbo will turn off. Yeah, so great. That works quite well and quite nicely. And of course, we can do this with the real chassis switch with this pin, as you've just seen. We can switch both the power and the turbo pins reliably. The other thing you need to be aware of when switching the turbo pin or the turbo mode of your power supply from the atxflip is the output of the turbo line is coming out not via one of these big screw terminals, but via one of these well, just turn off now. Like that. So the output of the turbo line is coming out of this pin, this little pin here, right here, and this is a single pin. You need to get yourself a Dupont header cable, which a female header on both sides, one to plug in here and one to plug into your motherboard. On the motherboard, you will probably find a 2-pin header, like, well, this one, with the difference that one of these pins is connected directly to ground and the other pin is connected to the chipset. You need to find out which one is the ground one and which one is the chipset one with a multimeter or something else like that, which you can check continuity with, because you need to, of course, hook this pin up to the one to the line that goes to the chipset, so the atxflip can tell the motherboard whether turbo should be turned on or off. And yeah, so you basically need to measure which pin is the ground pin and use the other one and hook the turbo line up to that, or you can just leave it free and don't switch turbo, or leave turbo permanently switched on, or yeah. Yeah. And the last feature of atxflip is this jumper down here. If we pull this jumper out and then do the whole restarting thing again, turn it off, discharge the internal capacitors of the power supply, and now turn it on again. As you have just seen, I've turned it on and the atxflip came on. I'll just turn it off here. Like that. And what this pin does, it's for remembering the last state that the board was in. So basically, if you turn off your PC with the hard power switch or by using the board, it will store in its EEPROM, internal EEPROM of the microcontroller, which the last state of the board was. And if you turn the power supply back on, the PC will either start or not start, and the turbo mode will be in exactly the state you left it in. So if we do a configuration like both on, power on, and turbo on, like here, both enabled, and then turn off the power supply, so and now turn it on again, it will come on right in the same mode, turning the PC on in turbo mode, and you will get your behavior like you want it. If we turn off the turbo mode now, like this, and then switch the power supply off, like that, and turn it on back on, it will come in right exactly in the last state it was, and, well, yeah, basically switch on your PC without turbo mode. So this is quite a nice way of using an ATX chassis for AT motherboards, as it enables you to, well, basically not drill any holes into your ATX case or do random other stuff like that. As I've already said in the beginning of this video, this is quite an old project. I started with TTL logic gates back in 2013, and only recently came back to remaking the AT Tiny version when after watching a video by Phil from Phil's Computer Lab, where he built an AT computer into an ATX case and struggled with the power supply and the power switch. Basically, he needed to drill some holes into the ATX chassis. That really wasn't the really nice thing, and I remembered this old project, and yeah, basically needed to pull it out again and doing some minor reworks here and there. And yeah, this is the current state of the project, and think I'm quite happy with it. You can find more information about the project as well as the source code and the hardware documentation on GitHub. And I'm always happy for bug reports, idea requests, feature requests, and stuff like that. So have fun, and I hope you enjoyed it.